determine a value a that makes it so that this limit exists. Well, in order for this limit to exist at -1, we'll notice that this is a piecewise function, so this piece and this piece meet at -1. So what you want to happen is that this function value must equal this function value at -1. So I'm going to sub in x equals -1 because that's where I'm concerned about the limit existing. So I'm going to plug in -1, so I get -1 cubed minus 4 times -1 equals 2 times -1 plus a. So what is unknown in this problem? Obviously the letter A. So therefore, this is just some sort of vertical shift to this line, and we just want to shift it up or down, however the case may be. So it lines up with this function here, and so the limit exists. So they're at -1. So as long as this function value and this function value are the same, we just need to determine what that a value is to make it so that both sides are the same, or these two function values at -1 are equivalent. So -1 to the third is -1, -4 and negative. I don't know why I'm doing that. You can do it in your head. This is -2 plus a. That's a sad looking a. So that's 3 equals -2 plus a, and a equals 5. So what is the unknown value a that makes it so the limit value at -1 agrees for this piecewise function? 5. And if you plug in -1 into this up here, you should get 3, because we already did that over here. Already got 3 right there. And so therefore, if I plug -1 in here, I get -2 plus 5, which is 3. So since the left-hand function value and the right-hand function value at -1 are the same, the function's limit at -1 exists. Sorry, a little pause there on my computer. So here's the integer function, greatest integer function. In your calculator, if you want to take a look at it, I don't know why that just happened. Want to take a look at it in your graphing calculator? You can go to y equals. I'm not going to pull up my graphing calculator because I already have a graph here for you. Go to y equals, and then go to math, and then num, and then it's the integer function. Integer, that's int. The integer function. And just make sure that you have it in dotted mode. So then go to mode and make sure it's dotted. And therefore you'll see this same function drawn here. So what does this do? This is just an integer function, so your function values are only integers. So if you have a function value, an x value of 0.5, what is the integer value associated with 0.5? 0. So if I have an x value of 1.5, what is the integer associated with 1.5? 1. If I have an x value of 2.662, what is my corresponding integer value? 2. If I have 2.9999999, which is really close to 3, what is the corresponding integer value for 2.9 repeating? 2. Okay, the only time it gets a little different is when you're looking at negative values. Negative 0.5 doesn't map to 0. Negative 0.5 rounds down to -1. Okay, so negative 1.2237, so negative 1.2, which is essentially here, rounds down to -2. So I think of it as like a rounding down function. X equals 0.5 rounds down to 0, 1.27 rounds down to 2, 2.38 rounds down to 2, negative 1.22 rounds down to -2, negative 2.78 rounds down to -3. Okay, so your negative ones go down in integer, your positive values just go down as well. So the question is, as x approaches 3 from the right-hand side, what is my limit value, or what is my function value? So 3 from the right-hand side, that means you're talking about 3.001. 3.001, what is the limit? What is the integer value associated with 3.001? Is 3. So therefore, the limit is 3. As x approaches 3 from the left-hand side, well, that would be 2.99999. What is the integer associated with 2.999? That's just 2 itself, so we're right here. So therefore, that limit is 2. And this says, do the left and right hand limits agree? And if they do, what is the corresponding value? Well, since the left and right hand limits do not agree. Excuse me, my limit doesn't exist. And why? Well, I don't have room, but I should write down since the left hand limit equals, excuse me, the right hand limit equals 3, the left hand limit equals 2. They're not the same, so therefore the limit doesn't exist. Sorry to take a drink. So let's look at negative values. So -2 from the left-hand side, what is a value from the left of -2? That'd be like -2.5. So again, it rounds down, so it wouldn't go down to -2. That would be going up. It goes down to -3. So here's -2.5. Excuse me, -2.5 rounds down to -3. So this is -3. -2 from the right-hand side. That would be something over here, -1.78. -1.78 rounds down to the next nearest integer, which is down to -2. And as x approaches -2, well, since the left limit and the right limit don't agree, this limit doesn't exist. So now we're looking at the limit as x approaches -1.5 from the right-hand side. So that's right around here. That rounds down to -2. The left-hand side of -1.5, so we're still at -1.5, just a little bit to the left. My function value is still going down to -2. And since the left and right-hand limits are the same, or equivalent, we can say that the limit itself agrees. Here's some pretty straightforward limit statements. We're given that the limit of f of x as x approaches 2 is 5. The limit is g of x as x approaches 2 is equal to 2. So these two both go to the same x value, but have two different functions, but two different limit values for different functions. Determine the following. Well, if you're finding the limit of the sum of two functions, it's the sum of the limits. So therefore, I can just add these two limits. So therefore, it's just 5 plus 2 is 7. If I'm taking the limit of a product, it's equal to the product of the limits. Well, here are the limits. Let's productize those limits, which would be 10. I just made that word up. A constant times the limit is still equal to the constant times the limit, so therefore just to be 3 times 2, which is 6. And finally, if I square it, it's just the square of the limit, which in this case is 25. I believe there's one more example. Yes, you've already viewed a video regarding absolute value, and if you haven't, I might go back to the website and check out how a absolute value is rewritten in piecewise form. I'm just going to rewrite the numerator of this thing of absolute value of x minus 1 according to the notes. If x is negative, not less than 0, if x is less than 1, and if x is greater than or equal to 1. That's how our piecewise function is broken up, because that's when it changes from a downward to an upward piece at 1. So this is the number 1. So therefore, this is the negative. So this would be, where is my little dot? This would be negative x minus 1, and this would just be the positive, stays as x minus 1. So you negate this side, the negative side, you leave the positive side alone. And again, if you don't understand this, you want to view the video about absolute values. This is an important part because the AP exam loves absolute values, and you need to be able to write absolute values in piecewise form. So this is looking at as x approaches 1 from the left-hand side. Well, that would be this top piece up here. So therefore, I'm just going to rewrite this absolute value in its piecewise form because I'm only concerned about the left-hand side. So that's the negative of x minus 1 over x minus 1. Those two cancel. I'm left with negative 1. Also, this is the right-hand limit. So the right-hand side, or the positive side of 1, my function value is defined. My function is defined by x plus x minus 1. So I'm rewriting the limit as x minus 1 over x minus 1. Those two cancel, and I'm left with 1. So therefore, this is the looking at the limit as x approaches 1. Well, since the left-hand side is different than the right-hand side, this limit doesn't exist. And that's since the left and right-hand limits do not agree. It's not equal to 1, which is equal to the right-hand limit. Graphically, what does this function look like? It's two horizontal lines, where here is positive 1. So the function values are always 1 on the right-hand side, So this is 1, and here's a closed circle, and here is -1. It's a horizontal line with an open circle at +1. So the limit values are always -1 from the left, and the limit values are always +1 for the right. So therefore at 1 itself, the limit doesn't exist because this doesn't agree with this down here. Okay, so that's an absolute value. And again, you need to, if you don't understand this setup here with the piecewise function, you need to check out the absolute value video that's located on my website, or just Google absolute value piecewise function. Okay, that's the end of that video. Thanks.